Hello.
Hello.
Hi, Rachel. How are you?
I'm great. How are you?
I'm good. Feeling better. I was not feeling well, so it's better now.
The weather.
Yeah, I'm better now. So you're using the headphone or nothing?
No, I'm not you. You hear me?
Yeah, but I feel it's just having some breaks in between.
Okay, I can put headphones in. I have headphones.
Okay, great. So till now we have completed nearly what? We have completed 33 questions out of 60 questions which will come in the SAT. I mean to say ACT. Till now we have done pre-algebra, which is 33 questions, and then we're having elementary algebra, which is 10 questions. And in them we'll be having functions, polynomials, linear inequalities, and exponents and square roots. So let's start with functions. By the way, did you try the questions which I told you on page number 1?
Yes.
Okay.
Oh, I didn't try questions, but I read more page. Oh, I forgot about that. I wrote it down and I didn't do it.
Oh, okay. No problem. You can do that after this session. So functions. In order to understand functions, let's take an example of a juicer, a machine which converts the different types of fruits into juices. For example, you want to make a mango juice, which is my favorite. So what you will do here is you'll put in the mango pulp in this juice. You'll put an input in this juice, that is the mango, and then you will get mango juice, right?
Right.
So if you will put banana, will you get mango?
No.
You'll get banana juice, right?
Yeah.
So that means for each input of this machine which we are putting in, we are getting a different output. We cannot get a same output. Are you understanding?
Mm-hmm. Yeah.
That means if we put mango, we will not get banana juice, we'll get mango juice. If we'll put grapes, we'll not get mango juice, we'll get grapes, juice of grapes or something. So that means this machine, what it does, it converts each input into its particular output.
Mm-hmm.
Right? There'll not be any possibility that one input will give you two outputs. It will never be possible. Right? One banana will give you like mango as well as banana, or mango or banana. No, it will not be possible. Are you following it?
Yeah.
So if there are numbers, if there are set of numbers 1, 3, 7, 9, and there are one more set of numbers, for example 2, 6, 13, 18, and I say that when there's a machine in between, and that machine is a function, what I will do here is when I'll put 1 in this machine, I'm getting 6. Okay. When I'll put 3, in this machine, I'm getting 2. All right. When I put 7, I'm getting 18. Okay. When I put 9, I'm getting 13. I can say that then this is a function, then this machine is correct. It's not having any problem, because for each input you're getting one output. You're not getting two outputs. Are you
Mhm.
following? So
Yes, I'm following.
so if I say to you that I'm giving 1 to this machine, I'm getting 2 as well as 6. So you have to say that then this machine is not a function, which is in between. Then this machine is not a function. It can
Oh,
be a
I get it.
relation. It can be a relation, but it's not a function. But you don't have to remember the relations and everything. You have to remember just one thing, that which one has to be a function, which one cannot be a function. So the input, if one input is going to give you 2 outputs, then that is not a function.
Mhm.
And if one output is gonna give you 1 output only, then that is a function.
Okay.
But there is one more problem. That is, I'm making, the I'm making the tea, which has came from Indian tea, or I'm making a tea which just came from Russia. So this is one variable, that is another variable. When I will put it in the function, I'm I'm getting, for 1 I'm getting 2, for 3 I'm getting 2. There's now one more problem here. For example, 1, 3, 7, 9, 2, 6, 13, 18. So in functions, it is not possible for one input to get 2 outputs. It's not possible. But in functions, it is possible that for 2 inputs, you can get 1 output. For 3 inputs, you can get 1 output. For Indian tea, you will get, when I will make it in the machine, you'll still get the tea, that is maybe 2. And for 3, which is the American or Russian tea, you are still getting 2. This is a different stuff here, which gets lost by most of the students. So
So it's not a function
um, remember the difference.
because they both go to 2, so it's not a function.
They both go to 2. What is the difference between the first example, I mean to say the top one and the bottom one? One input is giving you 2 outputs. Remember, one is giving you 2 as well as 6. And here 1 is giving you 2 and 3 is giving you 2. So there's a difference between the two examples. You're having, I told you the definition of function. Each input will be having only 1 output. Each input cannot have more than 1 output.
Oh, okay. So these inputs
Right.
are getting the same output, so it still can be a function.
Yes, exactly. So it can be a function, correct? But this bottom one cannot be a function because each input has to have 1 output. So it's having single input, you're getting 2 outputs, it is not a function.
I see.
Let us take an example. For example, we're having a function machine called y equals x squared. And we'll be having some inputs which will feed in to this machine, and we'll see what will be the outputs. And then we will analyze whether this y equals x squared is a function or not. Let us take -1, 0, 1, 2, 3, and 4. So let us put in -1 in this function machine for x, because x has to be the input. And when you will give x as the input, you will get the output as y. So what will be y when you'll put x as -1? Y equals -1
Negative
squared.
1.
-1 squared, right? Because y equals x
Yeah.
squared. So how much is -1 squared?
That's positive 1, right?
Positive 1, correct, yeah. That's positive 1, because negative times negative will be positive. So for -1, you are getting positive 1. Okay, what about when you'll put in 0 for x?
That's 0. Y
Right,
equals 0 squared.
0 squared means 0, right?
Yeah.
So it'll be 0. What about when you'll put in 1 as the input?
That would be 1.
1, correct. 1 squared is 1. What about when you'll put 2?
That's 4.
That's 4, correct? So
Mhm.
let's keep it there only, these many things. So is it a function?
Yes.
Yes, it is. Now, you can see one thing here. -1 is also giving you 1, and 1 is also giving you 1. So you don't need to write 1 2 times. You can just write it at once, and you can put 1 also giving 1. So is it a function?
I'm sorry, can you repeat it?
Yeah, -1 is also giving you 1, right? And 1, when you'll put in 1 to this function machine, you're also getting 1 again.
Yeah, it's still a function.
Very good, correct. So this is still a function. Wonderful. Now, the functions, for example, y equals 2x squared minus 3x plus 4. This will also be a function. It will also be having the same thing as we did right now, that each input will be giving you one output. But the functions is written as, f of, this y is written as f of x. It's just a fancy way of writing y and nothing else. Just the different way of writing y. F of x equals 2x squared minus 3x plus 4 and nothing else. So when you plugged in x equals 1, the same thing has to be done here, but you can write f of 1 because you're plugging the value of x as 1. So it'll be f of 1, function of 1 is equal to 2 times 1 squared minus 3 times 1 plus 4. Wherever there is x, you'll plug in 1.
And you got the equation from where?
This is just my example.
Okay, so just plug it in.
Plug it in, that's it. Correct. So I'm telling you that this is a function. It's in the question. F of x equals 2x squared minus 3x plus 4. It's a function. So what can be the value of f of 1? F of 1 means what is the output when the input is 1? Simple. What is the output when the input is 1? So I'll write f of 1 equals 2 times 1 squared minus 3 times 1 plus 4. Wherever there is x, I will put in 1. Are you getting?
Yeah.
So how much will be 2 times 1 squared minus 3 times 1 plus 4?
2 times 1 will be 2, and then you square it, right? So that will be 4.
But squaring is with what number? Is it with 2 or with 1?
with the 1.
So 1 squared, how much? You have to first calculate 1
1
squared.
squared
1
is
squared is how
1.
much? So 1 times 2 times 1.
2. And what is the thing next to the square? What is that thing up
There's
there?
nothing.
Yeah, that's
There's nothing. This is just the previous example, something. So here, 3 times 1.
3 times 1. That's negative, right?
Yeah, it'll be negative here. Negative 3.
So negative 3 and then plus 4.
How much is it?
So you have to like add 3, right?
You can use the
Or no?
calculator now in order to make yourself, protect yourself from confusion. You can simply use the calculator. 2 minus 3 plus 4.
So 2 minus 3, negative 1 plus 4.
Mhm.
So negative 3. I mean positive 3.
Positive 3, exactly. So f of 1 is positive 3. That means when you will put in the function machine the input as 1, you are getting output as 3.
I see.
Okay, so this, this will be the way of writing the functions. Fancy way of writing y is f of x, that's it. And if we want to calculate the values of, the functions at any point, we have to simply plug in the value at that point. For example, this same example is here. For example, we are taking this same example, and the question is, what is f of 2a for this question? So wherever there'll be x, you have to plug in 2a.
3. Oh.
2a. Whatever is here.
So
F
whatever
of,
is in parentheses, you
yeah,
have to plug into x.
correct. Yeah. Whatever is in parentheses, you have to plug it in x. So it'll be 2 times 2a squared minus 3 times 2a plus 4.
Okay.
And then you'll first calculate what is in the parentheses. 2a whole squared. How much is that? 2a whole squared.
4a. No.
Yeah.
2 times. Okay, so it
Yeah.
would be 4a and then times 2. And then
1 second. 2a whole squared means 2 is also having a square and a is also having a square. So whenever you're having in parentheses, you're having the power. So whatever is in the
like
parentheses,
4a
yeah, you have to give,
squared.
yes, it'll be 4a squared, correct. And 4a squared multiplied with 2.
8a squared.
Correct. How much will be negative 3 times 2a?
Negative 6a squared. No, not squared.
Yeah, negative 6a only.
And plus 4.
Correct. So this is the value when you are putting in the value of x as 2a. So f of 2a is equal to 8a squared minus 6a plus 4.
I see. So you cannot make it any smaller?
No, if it is given that a is 1, sometimes the question is telling you a is 1, what is the value of what is the value at that moment? Then you can plug in the value of a is 1 and solve it. It depends on the question.
If I would have been doing the question, I probably would have done something like subtracting 4 and then subtracting or adding 6.
Yeah, that'll be only possible when we're having equality sign and you'll be having something on the right side, isn't it?
Okay, makes sense. I never knew that.
Because an expression, you cannot do anything with the expression unless you plug in something. For example, you're having 3a squared minus 2a plus 2. What you will do with this if this is the only thing there? Unless you're having 3a squared minus 2a plus 2 equals 4, for example. Then you'll be, simplifying it a little bit and trying to solve it, isn't it? So we'll do one more thing after this, that is the quadratic functions, and it'll be more clear. But till now, we have to understand that the functions means, you know, y equals some polynomial, some expression, but this y has to be written as f of x or f of something, f of, you know, a, f of 2, f of 1, f of anything equals that whole thing. So whatever is in the parentheses, you have to plug it in this expression, which will be on the right side.
Okay, I get this concept now.
Great. So let us take some function here. Let us take y equals x squared, which we did. Y equals x squared. So this is a function. And for each you know, input, you're having one output. You're not having for one output, you're not getting for one input, you're not getting two outputs. For one input, you are not getting two outputs. So we can say that it is a function. You know, what is the best way of analyzing whether the graph is a function or not? We call it vertical line test. Vertical line test. What we do here is we make a line, vertical line, anywhere. For example, this, like this, like this, and see, is there any point where this line cuts the graph at more than one point?
No.
That means it is a function. As simple as that. Because each input will be having one output. Each x value will be having one y value. For example, if I will take this point here, the value of x is 2 and the value of y is 4, 2, 4. If I will take this point here, the value of x is 1 and the value of y is also 1. If I will take this point here, the value of x is negative 1, and the value of y is 1. I'm not having.
Okay, so whenever you said the vertical line, if it doesn't pass more than 2 points, you said that would be a function or not a function?
More than 1 point. If it is not passing for more than 1 point, then it is a function. But that means if it passes at only 1 point, it is a function. Only 1 point. Okay. So vertical line, making a vertical line everywhere, and see if it passes for only 1 point. If it cuts it at only 1 point, if it is cutting it at only 1 point, then it is a function. Right?
Right.
So if I'm having a graph like, I'll make it. For example, I'm having a graph like this red spiral type something. So I'll again do the same thing. I'll put in the vertical lines.
So on the left is not a function.
It's not a function because it's crossing the graph at more than 1 point. 1.
The other lines are a function?
No. We have to completely see this. If a person you know, if a person's hand is infected, will not allow him completely, right?
Oh, so the other lines are infected too, and they're also not functions.
This will be one graph, isn't it? This line, this will be one graph. So if there's problem at any point, then this whole graph is not a function.
Got it.
Because it's crossing the graph. The vertical line is crossing the graph at more than one point. So that's why it will not be a function. But this is a function which I have made. It's called parabola. Y equals x squared. So this is a function. Now let us move to the next one. Oh, I have done a lot here. All right. So the second thing here is, okay, here also we have an example. F of x equals x squared minus 3x, and we have to calculate the value of f of 5. So can you calculate the value of f of 5 for this function?
You have to put 5 in where the x is, so it would be f of 5 equals 5 squared minus 3, 5.
Yes,
I don't know, 3 times 5. Yeah.
Yes, 3 times 5. Yes.
Do you want me to solve it? Like write it and solve it?
Yes. Yes.
So f of 5 equals 25 minus 15. So should I subtract 25 from 15?
Definitely, you have to. How much would it be?
F of 5 equals 10.
Correct. F of 5 equals 10. That is the answer. Now
I understand now.
Great. So let us move now to the polynomial operations. Before understanding polynomial operations, we have to understand a term in mathematical concept, in mathematical way. A term is actually a multiplication or division of variables and numbers, and nothing else. For example, 2x, it's a term. 3x squared, it's also a term. Negative 4xy is a term, right? Simply x is also a term. Now, if I'll combine these terms, for example, by adding or subtracting them, 2x plus 3x squared minus 4xy, now we are having 3 terms, 1, 2, and 3, right? And if I'll be having one more example as negative 7y plus 2y minus 3x squared y. This is also combination of terms. But in the first example, you're having 3 terms, 1, 2, and 3. And we have to analyze whether these three terms are like or unlike. So I have told you perhaps, what do you mean by like term and unlike term, maybe? So no.
I think like term would mean that they have the same, what's it called? The letter? It's called
variable,
a variable or
variable.
So it means they have the same variable, right?
And the second thing, the power on the variable has to be same. Two things. For terms to be like, they should have same variable, and the power on the variable should also be same. For the terms to be like, they should have same variable, and the power on variable should be same.
Okay, I see.
So if it is 2x and 3x squared, well, the variable is same, x and x, but the power is different.
Yeah, so they're not like terms.
Correct, they are not like terms. So you cannot combine them then. If they are not like terms, you cannot combine them. So we can say that this is, this is a combination of the terms where we are having at, three terms. And what about the second example?
The first two are like terms.
Right. So first two are like term, -7y plus 2y. So can you combine them?
Yes.
So how much will it be?
It will be -5y.
Correct. -5y minus 3x squared y. So now, actually, it was written as three terms, but it is actually only two terms. Right?
Right.
Now let us understand what a polynomial means. If you're having combination of terms, for example, in the above case, you're having three terms, in the below case, you're having two terms, but the combination is such that the variables are having the powers as integers. Remember, the variables are having the powers as integers, like not actually integers, whole numbers. 2x plus 3x squared minus 4xy. Let us analyze the powers on the variables. What is the power for x in this 2x? 1. And what is it in 3x squared?
2.
And what is it in 4xy? X has how much, and y has 1 and 1. So 1, 2, 1, 1. These are all whole numbers or natural numbers, right?
Right.
If you're having the combination of the terms where we're having the variables and the variables are having the powers as whole numbers, or you can say natural numbers, then we can say that that combination of terms is a polynomial.
Can you repeat the last sentence?
Yes, that combination of terms is a polynomial.
And what qualifies it to be a polynomial? Is it if they have whole number exponents?
Correct, if they have whole number exponents. If they have whole number exponents, then that qualifies them for the polynomial. Makes sense. This thing means that you will not be having the variables in the denominator. For example, you cannot have 2x by y, because when you are dividing by y, it is, it's in the denominator, so it's not having the exponent as +1 actually, because when you will take it in the numerator, it'll be actually 2xy to the -1. Whenever you're having anything in the denominator, anything, for example, 2xyz divided by 3x squared y squared z squared. So we cannot judge by just seeing this thing that is it a polynomial or not. We have to convert everything. We have to write everything in the numerator. So I'll write 2xyz as it is, but 3x squared y squared z squared, if I want to write it in the numerator, I have to change the sign of these exponents which are in the denominator. For example, 3 is having raised to the 1, it'll be 3 raised to the negative 1. X to the 2 means x to the negative 2. Y to the 2 means y to the negative 2. Z to the 2 means z to the negative 2. So whatever you're having in the denominator, you can write it in the numerator. You can write it, but you have to change the sign of the exponent.
I don't quite understand this part.
Yeah. Okay, 1 second. I'll just give an example. If for example you're having 1 divided by x somewhere, this x is having a power of 1. Now you want to analyze whether this is a polynomial or not. For analyzing whether this is a polynomial, you have to write every variable in the numerator. And you can write every variable in the numerator which is in the denominator. You can write, but there's one rule for that. You have to change the sign of that exponent. You have to change the sign of the exponent which is in the denominator. 1 divided by x to the 1 can be written as x to the minus 1 in the numerator. It is one and the same thing. 1 divided by x to the 1 is equal to x to the minus 1. We can use the calculator. We can see there also.
So it always has to be negative when you do that?
You have to change the sign. If it is negative in the bottom, then it'll be positive. Just changing the sign. If it is 1 divided by x to the negative 2, when you will write it in the numerator, it'll be x to the 2. You're changing the sign.
Yeah.
I'll write it in the calculator. So if you're having okay, so if you're having 1 divided by 4 squared, 1 divided by 4 squared, that'll be 1 divided by 16, obviously, and that'll be 0.0625, right? 1 divided by 4 squared is 0.0625. But when I will use the the rule which I told you, 1 divided by 4 squared can be written in the numerator also as 4 to the negative 2. Changing the the sign on the exponent. Right?
Got it.
So now I will check what is 4 to the negative 2. I'll check what is 4 to the negative 2. It should come out to be the same, 0.0625. So 4 to the negative 2. 4 raised to the power negative 2. This is equal to, again, 1 divided by 16. And when you'll solve it, it is again 0.0625.
Oh, okay, I see.
Right? So 1 divided by 4 squared is same as 4 to the negative 2. The same value, 0.0625, 0.0625.
Okay, I see.
In the same way, I can write 1 divided by x squared is same as x to the negative 2.
Yeah, I see.
Great. So that is what I was saying. If you're having where we are, right here. So if you're having something in the denominator, then you have to first write it in the numerator and see whether the exponent is a whole number or not. If the exponent is not a whole number, then that is not a polynomial, right? That can be a general expression, but that is not a polynomial.
So if it's negative for the exponent, can it be a polynomial?
It cannot be a polynomial because negative is not a whole number, right?
Right.
So that is about polynomials. But if you're having only one term in the polynomial, for example, you're having 5y, then the name is called monomial. It's just one, exactly. If you're having two terms, 5y plus 3x squared, two different terms, then it is binomial, right? And if you're having three terms, negative 7y plus 2y minus 3x squared y, then it is a trinomial. The name only, the name suggests what it is. Monomial. So polynomial is
trinomial also a polynomial?
Yes, trinomial is also a polynomial. Polynomial is a general name. For example, students. Students is a general name. But in students, you're having 10th grade also, you're having 9th grade also, you're having 8th grade also, you're having even 1st grade.
So monomial is a polynomial?
Correct, yeah. We say that these are all polynomials, but if it's only having one term, then it's a monomial. If it's having two terms, then it's a binomial. If it's having three terms, it's a trinomial. And if it's having more than three terms, we say in general, it's a polynomial. That's it. Right? They're all polynomials. So we can also solve polynomials as we solve the functions. We can do the same thing to the polynomials. For example, you're having a question here. You're having a question here for solving the polynomial. Can you try to solve this question? Same thing which we did for functions. This is the question. For x equals -2, solve 2x squared plus 14x plus 8.
I'm gonna try.
Okay.
Negative 196.
Negative 196. So did you plug in for x as -2?
Yes.
Okay, I'll also do the same thing. 2 times -2 squared plus 14 times -2 plus 8. Did you write the same thing?
Yes.
So how much is -2 squared? Because you have to do for, PEMDAS, you have to go for exponents.
So -2 times -2. Oh, it's supposed to be positive.
Yes, it'll be +4.
I accidentally wrote -4.
So that might be the mistake.
Should I redo it with that correction?
Yes, yes.
So this time I got -12.
-12. That is correct. -12 is the
Oh,
answer.
yay.
Beautiful. So at the same time, you will be asked for multiplying, dividing, adding, or subtracting the polynomials. So for example, you're having here 2x squared plus 14x plus 8, and you're adding 3x squared plus 5x plus 32. So you will only add or subtract the like terms. You can multiply or divide any term, whether it is unlike, whether it is like. You can multiply or divide any term, but you can add or subtract only like terms. Right?
You said, okay, multiply and divide any term.
Yes, you can.
Even if it's not a like term.
Whatever it is. Multiplication and division, is does not need any, likeliness. You can multiply anything with anything.
And then add and subtract only like terms.
Correct. You can add and subtract only like terms. So if you're having 2x squared plus 14x plus 8 plus 3x squared plus 5x plus 32, which terms you'll combine? What can be the answer to this addition?
The top and the bottom you can do, right? Or
yes,
you only do left to right? Okay, so 2x squared and 3x squared, so you add them and get 5x squared. And then 14x and 5x, so that would be 19x, and then 8 and 32, and it's 40.
Wonderful. So you have added the polynomials. See, the question, the answer is same. 5x squared plus 19x plus 40. And the same thing can be done for subtraction. But you have to remember that when you will put in negative sign to the next polynomial, the sign will get changed for every term there. For example, 8x squared plus 11x plus 23 minus this whole polynomial, then you will take, you know, the negative sign for everything, because they're all positive. Their negative, their sign will change from positive to negative when you're subtracting. So how much will it be? 8x squared minus 7x squared.
X squared.
And how much will it be? 11x minus 3x, because now you're subtracting.
So it would be 8x. That will confuse me. I probably have to write over the plus sign, a minus. And 23 minus 13.
What you can do here, you can just write it as
10.
You can write the question like this: 8x squared plus 11x plus 23. Then you'll write minus 7x squared plus 3x plus 13. Now you can solve it. You can write 8x squared plus 11x plus 23. This minus is in multiplication with everything, right?
Right.
So minus times positive 7x squared will be negative 7x squared. And negative times positive 3x will be negative 3x. And negative times positive 13 will be negative 13. Then you can combine 8x squared and negative 7x squared.
I think it's easier to do it the other way.
Like it was here?
Yeah.
Yeah, because you're having the like terms near each other. Negative 7x squared is here, negative 3x is here, negative 13 is here, so it becomes easy. That's right. So how much will it be?
You want me to do it the easy way or the other way?
If it feels
easy,
asking? If it feels easy for you like this, top and bottom, then no problem, you can do that. But you should also be able to, you should be also able to do it in the other way, because sometimes the equations are written in a, you know, in a horizontal form.
Can you show me the other way again, because I wasn't following it?
No problem. First you try to do it in the top and bottom way.
So this would be 1n squared, and then 11 minus 3 would be 8n, and then 23 minus 13 will be 10.
So it'll be x squared plus 8x plus 10. It's x, not n, right?
Oops. I thought it said n.
No, it is x. Now what I did here, I wrote the first polynomial here, 8x squared plus 11x plus 23, and then I wrote the second polynomial here, you know, 8x squared plus 11x plus 23 is the first one, and then subtracting 7x squared plus 3x plus 13, right?
Right.
Now this negative sign is outside the polynomial, outside the second polynomial. This negative sign is outside the second polynomial. Now, in order to, you know, open this parenthesis, I'll just multiply this negative to every term in the polynomial. Actually, this negative is negative times 1, because you're subtracting. Subtracting means, you know, the sign will be changed. Positive 7x squared will become negative 7x squared. Positive 3x will become negative 3x. Positive 13 will become negative 13.
Right.
And then I can combine the like terms. I will see out of these 6 terms, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Out of these 6 terms, which ones are, you know, like? So I'm getting first and the fourth term is like, because they both are having the same variable and the power on the same variable is same. So 8x squared minus 7x squared will be 1x squared, that is x squared. And then I will see again any like term. Second term and the fifth term is like, because same power and same variable on the same variable and same power on the variable. So 11x and negative 3x, it'll be positive 8x. And then I will see again any likeliness. So 23 and negative 13. Third and the sixth term, it'll be positive 10. So that'll be the answer. Confusion, right?
I see. Can we just go through it quickly one more time? Just very quickly. Because I pretty much understand it. I just wasn't following for one part.
Okay, so let us do another example of addition and subtraction of polynomials. You're having a polynomial 4xy minus 3x squared. This is one polynomial, and you have to add it with 3xy plus 2x squared. You have to add it with this. Now, in order to add it, you have to see the like terms. So you can write as 4xy minus 3x squared plus 3xy plus 2x squared. Now, this is the whole polynomial. Now, can you see the like terms and unlike terms?
Yeah, I see.
Which one? You can combine
2x squared and negative 3x squared, and then 4xy and 3xy.
Yes. So can you tell me the answers? Like how much will be 4xy and positive 3xy?
This would be 7xy.
And how much will it
and
be?
Then negative 3x squared plus 2x squared. This would be x squared.
Negative 3 plus 2.
Squared.
Negative 3 plus 2.
Oh, yeah. It's negative 1x squared.
Exactly. Negative 1x squared. And we don't usually write 1, so it'll be negative x squared. So 7xy minus x squared will be the addition of these two polynomials.
Right.
This is the polynomial 1. This polynomial second. This was the addition of these two polynomials. Now let us subtract these two. So for plus sign in between, I will write the negative sign in between. Now I can write it as 4xy minus 3x squared. Now this negative sign will be, distributed to 3xy and 2x squared. So negative times positive 3xy will be negative 3xy, and negative times positive 2x squared will be negative 2x squared. Now I can solve it. Are you following what's happening when we are subtracting?
Yes, following.
So we are just distributing this negative sign to the second polynomial. So if there'll be any negative sign in the second polynomial, that'll become positive, and if there's any positive sign, that'll become negative. So positive 3xy became negative 3xy, and positive 2x squared became negative 2x squared.
I see.
Now, can you solve this? Can you combine the like terms?
So 4xy, this would be negative 4xy, and then minus negative 3xy. This is xy.
4xy minus 3xy will be xy, right?
And negative 3x squared is 2x squared.
Negative 3x squared, negative
1x squared.
Negative 3x squared, negative 2x squared.
Oh, okay. So you're subtracting them, right?
Yeah, negative 3 minus 2.
Negative 3 minus negative 2. So this is negative 5x squared.
But it is already, we have already distributed this negative sign. We don't need to now, subtract it again. When we distributed this negative sign to 3xy and 2x squared, it became negative 3xy, negative 2x squared. Now we don't need to just subtract this again. We have to just follow, what is the sign? What is the sign? We have to follow accordingly. 4xy minus 3xy will be xy. Negative 3x squared minus 2x squared will be negative 5x squared.
I see.
Right? For example, you're having 2x plus 3y minus 3y. You're subtracting it with 3x and plus 4y. You're subtracting it with this. So what you will do is you will write 2x minus 3y, and this negative sign will be distributed here. It'll become negative 3x, negative 4y. And now you can combine the terms. 2x minus 3x will be negative x, minus 3y and minus 4y will be minus 7y.
Got it.
Right?
Mm-hmm.
Is it clear, or should we repeat it?
It's very clear now.
Okay.
I completely understand this concept now.
Wonderful. Now let us move to the multiplication, because we did the addition and subtraction of polynomials. Now let us do the multiplication of polynomials. You're having 2x as a polynomial, and sometimes it's said multiply 2x with 3x plus 4. These both are polynomials, and you have to multiply them. You will do the same thing as you did for multiplying of numbers. For example, you're having 2 times 3 plus 4. 3 plus 4 were in parentheses, so you could have done PEMDAS, or you could have used the distributive property. 2 times 3 plus 2 times 4. So this would have been 2 times 3 plus 2 times 4. This would have been 2 times 3 is 6 plus 2 times 4 is 8. In the same way, if you're having 2x times 3x plus 4, you will use the distributive property. This 2x is to be multiplied with 3x, and this 2x is to be multiplied with 4. So 2 times 3x, 2 times 2x times
6x
3x
squared.
right, plus 2x times 4. So 2x times 3x will be
6x squared
plus 2x times 4,
8x.
right. So that is the multiplication of the polynomials. Now let us take binomials and binomials. For example, 2x plus 3 multiplied by 3x minus 2. Have you heard about FOIL?
Yes. So what I was confused about, and I think what I was getting wrong, is I didn't know the rule where you can only do like terms for addition or subtraction. And I was confused like why I would see people doing it for division and multiplication, because I thought it was a rule. So this makes things more clear.
Great.
And I heard a FOIL.
That's beautiful. So in case of FOIL, this thing makes me happy, when you say that it becomes more, sensible now. It becomes more,
It is
clear.
years of confusion.
I think we are doing 5 years mathematics in few days. Like
I think so too.
maybe starting from 6th grade, fractions and everything. So we are doing it in a very fast way, and you're just grasping it in a great manner. Wonderful. So 2x plus 3 times 3x minus 2. So if a person will get, the right way of, analyzing the things before, maybe in 6th grade, if you were having this type of knowledge, then obviously you might be, flying in air right now.
Yeah, but I didn't.
Yeah.
Because I didn't have a teacher. She left us.
Oh, okay. That's where the problem happened. No problem. So let's do the multiplication of these binomials. So how do you do that? How do you FOIL?
2 times 3, that would be, it's x, right?
Yeah, it's 2x and 3x.
2 times 3, that's 6x, and then
Is it x only?
squared.
Right. So it'll be 2x times 3x. This will be the firsts. And then
3 times. Oh, no, you have to do 2 times -2. That's -4.
2 times -2, that's -4. But x is there, right?
Yeah, -4x.
And then inside
3 times 3. So that's 9x.
And then
And
last.
then 3 times -2, that's -6.
Right. So 2x times 3x will be 6x squared. So write as 6x squared. So we got the 4 terms. And then we have to see, is there any like term? So that we can reduce it again.
Yes, there are like terms. So -4x and 9x.
Right. So how much is -4x and 9x?
+5x.
Positive 5x. And we're having -6 here. So this is the answer for multiplication of these two terms.
Makes sense.
2x plus 3 times 3x minus 2 equals 6x squared plus 5x minus 6. And you know what? In a calculator, you can simply convert this 6x squared plus 5x minus 6 into this. You can make it in factors. For example, see, 36, can this be written as 12 times 3?
Yes.
So 36 has been written in factors, in its factors. And it's one of the two factors. Like, there are many factors for 36, but just two factors I have taken, 12 and 3. I have multiplied them and I got 36. So I have written 36 by its factors. In the same way, this is some, this is some, term. This is some polynomial, 6x squared plus 5x minus 6. I can write it in its factors, 2x plus 3 and 3x minus 2. These are its factors.
I see.
Right? So when I'll multiply these two factors, I'm getting the polynomial. It is the same as if I'm multiplying these two factors, 12 and 3, I'm getting 36. Right?
I see.
So
right.
if you'll divide by 3, if you'll divide one of the factors out of these 12 and 3, if you'll divide by 3 to both sides, won't you get another factor like 12? If you'll divide by, for example, if you'll divide by 3 to 36, won't you get another factor 12?
Yes.
So the same thing can be done here. If you'll divide 6x squared plus 5x minus 6 with 3x minus 2, with 3x minus 2, you know what you will get? You will get another factor, that is 2x plus 3.
I'm sorry, can you repeat the last part?
Yes. As I told you here in 36, if you'll divide 36 by 3, you are getting another factor 12. 36 divided by 3 is 12, right? That another factor,
Right.
which was in multiplication with 3. In the same way, if you divide 6x squared plus 5x minus 6 with one of these factors, you will get another factor. For example, if you divide 6x squared plus 5x minus 6 with 3x minus 2, you will get the answer for this division as 2x plus 3, another factor, as you got here, 12. But how to do that? That's a different case. But when you will divide by any factor, when you divide the polynomial with one of its factors, you will get another factor as the answer. Right? When you divide 36 with one of its factors, maybe 3, you will get another factor as the answer, that's 12. But if you divide it with 12, you'll get another factor as the answer, that's 3. Are you following?
I'm following.
So the same thing is happening here in polynomials also. Division by any factor to the polynomial will give you another factor of that polynomial. Right?
Following.
All right. Now,
it all makes sense to me.
Wonderful. Now what we can do here is, I think linear inequalities with one variable will start in the next session. I just want to, I'll give one question for multiplication, and that's it. We'll stop there. 9x minus 3y times negative 2x plus 4. Can you try it?
What I got is negative 18x squared plus 36x plus 6x minus 12. And I don't know if I need to simplify it further.
Negative 18x squared and then?
Plus 36x plus 6x minus 12.
Okay, so 9x times negative 2x will be negative 18x squared, and then you'll be having 9 times 4 is 36, and then negative 3 times negative 2 will be positive 6. But there's, you're multiplying negative 3y and negative 2x, how much you're getting?
It would be yx.
Yx, exactly. So it'll be yx, 6yx or xy, it's one and the same thing. And then you'll be having negative 3y times 4. How much is it?
It's supposed to be negative 12y. For some reason, I wrote it as x.
Oh.
So it's supposed to be y.
Yeah, it's supposed to be 12y, negative 12y, correct. So this will be the answer to this, right? Is it correct?
It's correct. Do I need to do another step? Like I combine like terms now?
If you're getting any like term, then you can. If you're not getting any like term, then that is it.
There are no like terms.
So you can't move forward. So that is the answer.
Makes sense.
Great. And then maybe in the questions you might be asked, like, if x is 2, y is 3, what is the value of this polynomial? Then you can just simply plug in the value of x is 2. Wherever there's x, you'll plug in 2. Wherever there's y, you'll plug in 3. And then you'll solve it, you'll get the answer.
Wait, plug in what?
Plug in the values if it is in the question. Plug in the values for x as 2 and y as 3.
And then solve it.
And then solve it, and then that's the answer. If it is required, if it is given in the question, then only. Right?
Right.
So I think we'll stop here. Any questions for today? Any confusion? Anything? Because
tomorrow at 5, are we still going to do the session AM for 30 minutes?
We can, yeah, if it is possible for you. Or is it like, are you having some tight schedule, I think, right?
Yeah, I do have a tight schedule. I just think that I need to have a session every day.
Yeah, that's right. So we can have it, no problem.
Tomorrow. Actually, I think that 5:30 would be better.
Okay. 5 a.m. Yeah.
5:30 a.m.
5:30 a.m. Wow, beautiful. Right. So I'll still
that one will be shorter.
Yeah, it'll be 30 minutes session, and we are nearly done with elementary algebra. We're not shifting to intermediate algebra.
That's exciting. That's good news.
Yeah, that's good news, exactly, because then we'll be having 9 questions. Today we have completed nearly 10 questions out of 60 questions. Before that, we completed in these 3-4 days, we completed 33 questions from pre-algebra, and now intermediate algebra has 9 questions. So we'll be covering a lot. 9, 33, and 10. How much is that? 33 plus 10 is 43. 43 plus 9 is 52. So if we'll cover this intermediate algebra with good, with good strength, then we'll be completing 52 questions of ACT.
That's great news.
Yeah, but we need to practice a lot. Seriously, we need to practice a lot. The real questions which are coming in the ACT, we need to do that a lot. Then only it'll be more clear, like what's happening and which mistakes are occurring, again and again, and how can they be resolved, and how can I avoid the mistakes which I'm doing, like smaller mistakes, writing X instead of Y, writing negative instead of positive. Yeah, writing negative instead of positive and all that. So those also need to be eliminated, decreased a lot in order to increase the score. So it's a good idea that you're going for the ACT, because you can create wonders by using the calculator, which you have to do. Like you have to learn the calculator thing. You have to learn how to solve the algebra using the calculator, polynomials, like terms, unlike terms, everything, because everything can be done in the calculator.
I'm gonna watch some videos of how to use my calculator.
Yes, try to analyze like how to calculate how to combine polynomials on the calculator, how to add the polynomials, how to subtract the polynomials, how to divide the polynomials, how to multiply the polynomials on the calculator. So that'll be very, very helpful, because you can get the answer in few seconds and without any mistakes. So you will get the edge.
I have taken the SAT before. I just have not gotten my score yet.
Oh.
I think it was pretty bad. I don't think I passed it. So when I find out the math score, I'll tell you. And then next time I take the SAT, you can see my improvement.
Yeah. Yes, definitely. We have to see the improvement in the ACT, right? Because it's on 17th July. Yeah. Yep.
I've never taken the ACT before, so you won't know how much I've improved. But I'll take the SAT like probably in August maybe, and then you can see my improvement.
Beautiful.
From that.
Beautiful. So the SAT score when you will get, I can convert that into ACT score. There's a link for that. So when I'll convert that into ACT score, and then on 17th you'll be giving ACT, we'll be having new ACT score, and then we'll be able to analyze the difference and the improvements.
Great idea. So I'm gonna go now so I can go to sleep and then do the next lesson at 5:30 a.m.
Great. So 5:30 a.m. in the morning. Okay, fine.
Great lesson today. I learned a lot. Thank you. Have a good night.
Thank you very much.
Or day time for you. Bye-bye.
Yeah, bye. Bye.